Hello, this video is for Nova Online Math 161, and in this video we're looking at section 3.5, topic 3, solving log equations using log property. This is the second type of equation we're solving. We're solving the equation, we're writing the solution set with exact value answers. So the equation that we have is log base 5 of 26 minus x plus log base 5 of x equals 2. Notice they have the same log base 5 here, right? So we have log base 5 of 26 minus x, and the second one, log base 5 of x. They have the same base of 5. So when they have the same base, we can combine them into a single log base 5 using the log properties. Now, when these two separate logs are connected by a plus sign, we can go ahead and multiply their arguments. So what I'm going to do is I'm going to multiply 26 minus x times x. Okay, so we will be doing 26 minus x times x. And we'll set that equal to, just bring down that 2. So the first thing we did is using the sum property of log to combine two separate logs because they had the same base of 5 into a single logarithm by multiplying their log arguments. Okay, so I am going to distribute this x in and get log base 5 of 26x minus x squared. And on the right side, we still have 2. Now, to solve this log equation, we will now need to rewrite this into an exponential form. So let's rewrite this in exponential form. What is the base of this equation? The log base of 5. So we're going to say 5 raised to the what power? Second power, 5 squared equals, and bring down that log argument, 26x minus x squared. So what we just did is from section 3.3, rewriting log expression into an exponential form. And now we can go ahead and simplify and solve for x. 5 squared, I can write that as 25 equals, I have 26x minus x squared, but here's what I'm going to do. I'm going to move everything to the left-hand side. I'm going to move everything to the left-hand side so that we can solve for x. And I notice that x squared has a negative in front. So if I move that to the left, everything will, the negative x squared will turn into a positive x squared. So watch this, okay? When that negative x squared gets moved to the left side by adding x squared, the negative will now turn into positive x squared. Now, this positive 26x, to cancel that out on the right-hand side, to move it to the left, we have to subtract it, right? So the positive 26x will turn into negative 26x. But notice that 25 didn't really move. Okay, it's been on the left side the whole time. So we're going to just bring it down as a positive 25. So write down plus 25. And there's nothing left on the right-hand side when everybody moved. So we're going to just put the 0 right there. Now we're solving this quadratic equation, and let's try to do this by factoring. So let's think of two numbers that multiplies to be 25. What times what is 25? Well, I thought about 5 times 5, but notice that we want them to add up to 26, right? So I think we must be looking at 25 times 1, because 25 times 1 is 25, and if you add them, you can get 26. But if you want to add them and get negative 26, both the 25 and 1 must be negative. So now, when you're solving this, you're going to set this x minus 25 equal to 0 to get the first possible, solution to be x equals 25. And let's solve the other one. X minus 1 is equal to 0 when x is equal to positive 1, right? Now I circle them, but they may not be the final answer. So for when you are solving log equations, we always have to check for extraneous solution. So 25 and 1 are my candidates. I don't know if they are the real solutions, the true solutions. So here's what you're going to have to do, okay? I'm going to copy the original equation down here so that we can check for solutions, okay? So when you plug in these x values into the log expression, they must remain positive. The log argument must be positive. So imagine, look at this. If I plug in 25 in here, I'm going to get 26 minus 25. Is that a positive number? Yes, that's a positive number. So it passed the first check. Now, if I plug in this 25 in here, the log argument will just be 25. And that's a positive log argument. So 25, it passed the check. This is a solution. Okay, now let's plug in the other one. I'm going to plug in 1 now. If you plug in 1 into the log argument, I'm going to get 26 minus 1. Is that a positive number? Yes, that's a positive log argument. So the first part is okay. Now let me plug into the second part. Well, if I plug in 1 right there, then we have log base 5 of 1. And 1 is a positive number. So this case, both of the numbers kept our log arguments positive. So both are correct answers. Okay? Now, sometimes, now let's say that you solve this equation and you got something like x equals 30. Okay? If you plug in 30 in there, what will happen? You'll get 26 minus 30, right? And that comes out to be negative 4. But log argument cannot be a negative number. So sometimes when you guys solve log equations, you guys may get an extraneous solution. So that's why it is very important for you to check your answer. So I'm going to make a note. Check your solution to make sure that the log argument remains positive. So if you plug in a number and get a negative log argument, you're going to have to sometimes like cross it out and say that is not the answer. And sometimes that happens and all of your x values give you a negative log argument, then you're going to have to just say, hey, no solution to that equation. But this problem, we had to combine two separate logs into a single and solve the equation. But always remember, whenever you're solving a log equation, you must check for extraneous solutions.